On the next screen, we've started by taking the derivative of our quartic function, and the resulting derivative is a cubic expression. We're taking the derivative because we are trying to find the maxima and minima for this particular function, and that's found by taking the derivative and setting it equal to 0, which is what we've done. I've then noticed that everything is divisible by 4, so 0 is equal to x cubed minus 6x squared plus 10x minus 4. Now, this particular cubic equation must be solved. Unfortunately, it can't be factored. So, therefore, we're going to rely on our rational root theorem. And we start by looking at the ratio of a0 to an, which is a negative 4 divided by a positive 1. So our possible rational roots are plus or minus 1 divided by 1, plus or minus 2 divided by 1, and plus or minus 4 divided by 1. We find that p of 2 is equal to 0, so therefore, using synthetic division, we can find the other factor for this particular cubic expression. So we've done our synthetic division, and we've ended up with 1, negative 4, 2, and 0. If you remember, the 0 is the remainder, and if this is indeed, if 2 indeed is a root of this cubic expression, then the remainder after doing synthetic division should be 0, and that's the case here. So, based on this, we can now conclude that our cubic equation, which is 0 equals x cubed minus 6x squared plus 10x minus 4, can be factored such that it can be expressed as 0 equals x minus 2 times x squared minus 4x plus 2. Well, the roots to that are going to be x equals 2, and using your quadratic formula, you would find that when you solve that quadratic expression, x squared minus 4x plus 2, you end up with an x value of 3.41 and 0.59. Those are approximations. Now, these are going to be the maxima and minima for this particular function. We still need to know their corresponding y coordinates. So we take those x values and we substitute them back into our original quartic equation. And we find that when x is equal to 2, y is equal to 0. So actually that particular extrema is not only an extrema, but it's also one of the x-intercepts for the function. When x is equal to 3.41, my corresponding y is negative 4. When my x value is 0.59, my corresponding y coordinate is negative 4 also.